All right, today we're going to look at solving systems of equations that involve quadratics. Like these four examples from 4-9, and we're going to do all these using the graphing calculator, UE. You can go ahead and use substitution and do the algebraic methods to solve them. That would be great also, but I just want you guys to get more comfortable with the calculators, and plus you might find it's a lot quicker. So what we're going to do with these is we are going to enter each equation into the calculator. So the top one in example A will be y sub 1. The bottom one will be y sub 2. So on our calculators, what we're going to do is we are going to clear any equations we have, and we're going to shut off any plots that are on. And to shut off the plots, all you have to do is arrow up until it's flashing on plot 1 and hit enter. And then it will no longer be highlighted, so it won't be on anymore. So then to go back here, like I said, we're going to put x squared plus 6x plus 9 into y sub 1 and x plus 3 into y sub 2. So we have x squared plus 6x plus 9 in y sub 1 and x plus 3 in y sub 2. And we're just going to graph this on the standard window. We might have to do a little bit of adjusting to the window so that we can see the intersections. But we're going to start off just on the standard window. And to get to the standard window, you hit zoom and 6. And what that does is that gets both the x and y pieces of that window to -10 to 10. That's the standard window. Now we can see a couple of different intersections there, so we're going to calculate those. And hopefully from that applications packet, you guys know how to calculate those intersections. You go to second trace, option number 5. And it's going to ask you intersection of what, and you hit enter on first curve, hit enter on second curve, and hit enter again. So one of the intersections is the point -2, 1. So when you go back then on your worksheet, -2, 1, that ordered pair is one solution. So you can go ahead and write that down. Then we go back to the calculator, and we're going to calculate the other intersection. So we're going to second calculate intersection again. First curve, yes. Second curve, yes. But now if I hit enter, it's just going to give me the same intersection. So I'm going to arrow to the left until I'm closer to that other intersection, which is down there. And that intersection is -3, 0. So we have two intersections. We have two solutions to this system. The first one was -2, 1, and the second one was -3, 0. So you can write those 2 points down, and those are the solutions to that system. Solving algebraically, you would use substitution, put x squared plus 6x plus 9 in for this y in this equation. Then you could factor, complete the square, or use a quadratic formula to solve that. So next we're going to solve system in example B. And we're going to enter these two into the calculator again. And the top one's going to be -x squared minus 3x plus 10. And again, when you're starting off an equation like this, use this button down here for the negative, not the minus sign. So we have -x squared minus 3x plus 10 in the first equation. And in the second equation, I'll take a quick glance back, x plus 5 in the second. And we'll still graph on the standard window by hitting zoom 6, and we'll see what intersections we see. And we do in fact see both intersections there. So we're good to go. No adjustment to the window is necessary, so we're going to just go ahead and calculate the intersections. And enter on first curve, enter on second curve. First intersection is 1, 6, so right now write down the point 1, 6 as your first solution. Then we're going to calculate the intersection again to find that second intersection. However, when it gets to the guess, I'm going to move that cursor closer to that second intersection. As long as it's closer to that second intersection, then I will hit enter, and the second intersection is -5, 0. So that is your second solution. So we had 1, 6 and -5, 0 for our solutions for that one. Now we're going to go on to C, and then in C and D, instead of having a parabola and a line, we have two parabolas in those cases. So for the first one, in y sub 1, we're going to enter that first parabola, x squared minus 4x plus 5. And then in the second equation, we're going to enter the negative x squared plus 5. And once again, we're going to graph this on the standard window, zoom 6. And the blue one will be our first parabola, the x squared minus 4x plus 5. And the second one will be the negative x squared plus 5. And again, we have two solutions, 2 points of intersection. So we're going to calculate both of those. I'm going to calculate the intersection. And I got a little heavy fingered there. So we're going to go back to the graph. We're going to calculate the intersection once again. First curve, yes. Second curve, yes. And the intersection is the point 0,5. So right now, take a little bit of time. Write down 0,5 as one of your solutions. And then we will calculate the second intersection. First curve, yes. Second curve, yes. But we're going to want to right arrow now to that second intersection before hitting enter. And the second one is the point 2,1. So we have the point 0,5 as one solution and the point 2,1 as the second. And finally, we'll do the fourth example. The only difference in this one, the first equation is the same as C, but with D, we have the second equation being negative x squared minus 5. So we'll just go down and change that plus to a minus. And we'll zoom 6 again. And we will see that there is no intersection for that one. So that means there are no real solutions. Doesn't mean there aren't solutions. Those solutions happen to be imaginary, and we'll take a look at that Friday in class. What those solutions will look like, because they will be imaginary numbers. So for right now, for D, write down no real solutions. And in class, we'll talk about what those imaginary solutions will look like when we solve those algebraically.